Alright, so today we are doing our second quadrilateral. We're working on rectangles today. So the first thing we're going to talk about are the properties. And there are 7 properties for rectangles, but only 2 of them are new. 5 of them come from the parallelogram properties. So here are the 5 properties. The first one is that opposite sides are parallel. Second is opposite sides are congruent. The third one is opposite angles are congruent. Number 4 is that consecutive or same side, either word, whichever one's easiest for you, angles are supplementary. And number 5 is that the diagonals bisect each other. So remember, like I said, these first 5 properties of rectangles come from the parallelogram properties. So they carry over. So because a rectangle is a parallelogram, it also has these 5 properties. Number 6 is our first new property for a rectangle, and that's that all 4 angles in a rectangle are right angles, or they're equal to 90 degrees. And then the second new property, which is the 7th property for rectangles, is that the diagonals are congruent, so they're equal in length. So remember, these 2 right here are the new ones for rectangles. But all 7 are the properties of rectangles. So just because we have these new ones, it's not just those ones, it's also the 5 from the parallelograms. So the first example we're going to do is an angle example, and I'm telling you that quadrilateral ABCD is a rectangle. Now I'm also telling you in this problem that angle D, that's why the arrow points there, is 11x minus 9. So from our new rectangle properties, I know that all of these angles are right angles. So I'm going to draw my boxes on every angle because I know that they are right angles, which means that they are equal to 90 degrees. So I'm going to take what I know, angle D is 11x minus 9, but I also know that angle D is equal to 90 degrees. So I'm going to set them equal to each other. So now to solve for x, we're going to add 9 to both sides. So I end up with 11x is equal to 99. I'm going to divide both sides by 11, so x is going to equal 9. Now, if I was to plug that back in, it would give me 90, but here I'm just asking you for the value of x. So this problem, I tell you that quadrilateral GHIJ is a rectangle, and I want you to solve for x. So again, I tell you that this is a rectangle, and we're dealing with the angles. So I know that all of them are right angles, so again, I'm going to draw my boxes on them. Now I know that together they should equal 90 degrees. So before I just took one of them, set it equal to 90, and that was it. But this is 2 angles. It doesn't change. So I'm going to call this angle 1 and this bottom one angle 2. So when I add angle 1 plus angle 2, it's still going to equal 90 degrees. Now instead of angle 1, I'm going to write 3x plus 2. So 3x plus 2 plus, now instead of angle 2, I'm going to write 12x minus 17, and it's equal to 90. I'm now going to combine like terms. So I know I can combine the 3x and the 12x, which gives me 15x. And I have 2 and negative 17, which is negative 15, is equal to 90. I combine my like terms. I can continue solving for x now. So I'm going to add 15 to both sides. When I do that on the left, it cancels out, and I'm just left with 15x is equal to 90 plus 15 gives me 105. And my last step to solve for x is to divide both sides by 15. So x is equal to 7. I checked the problem. I asked you to solve for x. We solved for x, so we are done. So the next 2 examples we're going to do are going to deal with the diagonals. So the first one we did was with the angles because that was our first new property. And the second one is with the diagonal property that says that our diagonals are equal to each other. So they're the same length. If one of them is 8, the other is 8. So I give you this rectangle. It has its diagonals from A to C and B to D. So those cross sections are the diagonals, and they intersect at this point E. Now I want you to find all these things on the right, but I do tell you that AE, so that's from A to E, is equal to 12. Now from our parallelogram properties, we know that the diagonals are bisected. So when they intersect, they're cut in half, which means I have 2 equal parts. So if AE is 12, that also means the second part from E to C is 12. So I found that out. I know that AE is 12. I know that EC is 12. That's from that property that the diagonals are bisected. Now AC is this whole diagonal from A all the way to C. So we add the 2 parts together, 12 plus 12, and that gives us 24. Now I know my whole diagonal is 24 from A to C, because of the rectangles, hold on real quick, I know that both of my diagonals are equal to each other. So if AC is 24, that means that BD is also 24. Now, if the whole is 24, it's just like the other diagonal where it's bisected. I have two parts that are 12. So BE, which is from B to E, that one is also 12. And then ED, which is from E to D, is also 12. So remember, these two small parts, this BE and ED, that's for my property that diagonals are bisected. And then we have these two, AC and BD, which are our whole diagonals, the full length. This is from our new property that the diagonals are congruent. So because it's a rectangle, the diagonals are congruent or equal, whichever one is easiest for you to remember. So this is just with numbers. You'll have more examples like this. So I gave you this problem with algebra, and I say that quadrilateral LMNO is a rectangle, and I want you to solve for x. Now I have these arrows pointing that this part from P to M is 6x minus 13, and this part from O to P is 4x minus 7. Now, this isn't the new rectangle property where the diagonals are congruent because we're only dealing with one of them. This is actually the parallelogram property that it's bisected. What that means is that this part right here is equal to this part right here. If one was 4, the other was 4. We saw that in the example before. So in order to solve for x, we're going to set these two expressions equal to each other. So 6x minus 13 is equal to 4x plus 7. I need to solve for x, so I'm going to subtract 4x from both sides. When I do that on the right, it cancels out, and on the left, I'm left with 2x minus 13 equals 7. I'm going to add 13 to both sides. It cancels on the left, and I'm left with 2x is equal to 7 plus 13 is 20. And my last step to solve for x is to divide both sides by 2, so x is going to equal 10. My problem asked me to solve for x. I solved for x, so I am done. You do not have practice problems for this module. You actually have a minor assignment that's a writing prompt, so make sure you get that in and turned in because it is a minor grade.